Hey everybody, Miss Lewis here, and we are continuing on with the energy chapter. And today we are going to be talking about potential energy. The last class we talked about kinetic energy, which was the energy of movement. Potential energy is kind of exactly the opposite. So it's stored energy, energy that is ready to go but not going yet. It's stored. And it's due to the position of a non-moving object. So a potential something with like total potential energy has to be stationary. So as you could see, this football, the guy sitting, and the plant on the windowsill are all things that are stationary. They're not moving, but they do have the potential to move, right? The football has the potential to move, the person has the potential to move, the plant has the potential to move, whether it's picked up or knocked off of the window ledge. There are three different types of potential energy, just like, the three types of friction. There are three types of potential energy. The first is called elastic potential energy. And elastic is something that's like stretchy. Like when you think of elastic, you could think of like elastic waist pants or something like that. They're stretchy. And it's energy that's stored by something that can be stretched or compressed. So, for example, rubber bands, springs, they all have this potential energy, this elastic potential energy. It could be stretched and it could be compressed. So, let's say you have a spring and you push it all the way, you squeeze it all the way down. It has a ton of potential energy. It's just ready to spring up and, bounce away or something. Um, so it has a lot of that elastic potential energy. So anything that could be stretched, like I said, elastic waist pants, or even anything knitted, um, anything like stretchy. So yoga pants, leggings, um, rubber bands, obviously, hair ties, stuff like that. The second type of potential energy is called chemical potential energy. And this isn't something that you could see readily, like elastic potential energy. This is energy that's stored in a chemical bond. For example, gasoline. It's a chemical. It's just chilling, it's staying still, but it does have the potential to burn, and it has the potential to turn into other types of energy, like light energy if it's lit on fire, like thermal energy, anything like that. So, gasoline has potential energy until it is released when it's burned in a car. Something has to happen in chemical potential energy for it to kind of switch and make it into kinetic energy or thermal energy or light energy. So chemical potential energy is energy in a chemical that's just sitting and waiting to be kind of switched on. Another example is like a match. I've lit matches in class before, and it has like that little red top on it. That's chemical potential energy. It needs to be struck in order to release that potential energy. And the third type of potential energy, which is what we're going to be talking about today, and it's probably the most common type of potential energy, is gravitational potential energy, or GPE. Gravity means something that's falling to the ground. So, gravitational potential energy can be applied to anything that can fall but has not fallen yet. So, literally anything that is off of the ground. So, I don't know, a pencil on your desk, a key that's hung on a hook in your kitchen, a picture frame that's hung on the wall, you sitting on your bed. Any of that has gravitational potential energy, which means that it can fall to the ground. It doesn't necessarily need to be able to fall. Like, for example, like, let me think. If you tie a ball, let's say, to a tree branch, that has gravitational potential energy, even though if you tie a good enough knot, it's not going to fall. It just has the potential to fall, hypothetically, okay? So it doesn't necessarily need to be falling or almost falling, or ready to fall. It could be something that's kind of stuck there for a long time. It still has gravitational potential energy. And just like everything that we do in this class, it has a mathematical formula. So gravitational potential energy equals mass times gravity times height. And if you guys remember from the forces chapter that we did, you'll know that gravity, or the gravity constant, is 10 meters per second squared. Extra credit if you know the real one. It's 9.8. No extra credit. I was kidding. 9.8. So in a short hand, it's GPE, gravitational potential energy, equals mgh. And just like kinetic energy, it's measured in joules. So for example, if you have a gravitational potential energy of 30, you would say 30 joules. Okay? So it's basically just multiplying three things together. That's it. There's no division, there's no exponents, nothing crazy. It's just multiplication. So since mass of the object and height of the object from the ground both play a factor in GPE, two objects of different masses and heights can have the same gravitational potential energy. Now, this is a pretty complex concept that I don't expect you to understand right away, but here's an example for you guys. A 2 kilogram item, let's say a 2 kilogram box, that is being suspended 3 meters off the floor, is going to have the same potential energy as a larger box, a 3 kilogram box, that is lower off of the ground at 2 meters. You see that these two numbers are kind of switched. Both this one is switched with this one. So even though you have a smaller box in the first one and a larger box in the second one, the difference in height makes it have the same potential energy. So 2 times 3 times 10 is the same thing as 3 times 2 times 10, because it doesn't matter what goes first, right, in multiplication. So they are the same. So if you have a smaller object that's higher off the floor, it has the same GPE as a larger object that's closer to the ground. So your favorite part, let's practice. So a 0.06 kilogram tennis ball starts to fall from a height of 3 meters. How much gravitational potential energy does the ball have at that height? So we have our mass. You guys should already know that kg, kilograms, means mass. So that's 0.06. That's our mass. That's our m in the mgh. The g is, you guys should know that, 10. Okay, the g is always 10. And the height, or the h in the mgh, is 3 meters. So you literally just multiply these three numbers together. That's all you have to do. And when you do that, you will get 1.8 joules. All right? So we're going to practice. 1 second. Let me X out of here and go into this paint. Okay. So I am going to write the formula first. GPE equals mgh, where g always equals 10. Okay, so please excuse my handwriting, it's gross. Okay, so let's say that we have a potted plant that is on a windowsill. Okay, so our potted plant, let's say, is 3 kilograms. Okay, so our potted plant has a mass of 3 kilograms. And it is on the windowsill, and the windowsill is 1.5 meters off the ground. So its height is 1.5 meters. Okay, so we have potted plant, 3 kilograms, up on a windowsill that is 1.5 meters off the ground. And gravity, we know, is 10 meters per second squared. So let's plug this into the formula. So we have 3 times 10 times 1.5. Okay, let's go over to our calculator. Three times 10 times 1.5. You guys do it on your own. I'll wait. You better be doing it. Okay. 45. That is our final answer. So our final answer is 45. Now our gravitational potential energy is 45, but do we leave it at 45? No. What do we put at the end? We put joules. Okay? So the gravitational potential energy of this potted plant that is sitting on the windowsill is 45 joules. It has the potential to have 45 joules of energy. All right? So, oops, that is for my 7th graders. Okay, so if you have any questions, please let me know. You guys are going to be doing this practice today as your assignment. It's pretty straightforward. It's a lot easier than the kinetic energy formula. Let me know if you have any issues with it. Later on in the week, I will be holding virtual office hours. I will be posting a question probably today. I want all of you to answer it. Either you're coming or you're not. I want to know how many people are coming because sometimes I go on to virtual office hours and you guys say that you're coming and I sit there for, 15, 20 minutes and no one comes. So I want to know if you guys are coming. It's okay if you don't want to. That's totally fine. I just want to know. All right. So, like I said, if you have any questions, email me and have a good one.